Today, we are solving this question from JEE Mains 2025. Now, at first glance, you might think the effective resistance is simply 9 divided by 3 because of symmetry. But that is exactly where most students go wrong. So in this video, we will carefully break this problem down, step by step, and understand the correct approach. Welcome to the 5th video of the Current Electricity Numerical Series. Let's begin. This problem uses a very similar idea to the one we apply in a meter bridge. There, we consider the entire 1 meter wire as a single resistor, and then divide it using a jockey. In a similar fashion here, we assume the entire wire to be a uniformly distributed resistor of 9 ohms. So, mentally, we can replace this wire with an equivalent resistor like this. Now, let's take it one step further. Divide this wire into 3 equal parts, and then bend it into an equilateral triangle, as shown. Since the total resistance is 9 ohms, dividing it into 3 equal parts means each segment will have a resistance of 3 ohms. Now, let's rearrange this diagram into a more familiar circuit form. What we get is a triangle made up of 3 resistors, each of 3 ohms. And now comes the key moment. The question asks us to find the effective resistance between 2 vertices of this triangle. So, let's choose these 2 bottom vertices. Now, an important point to note here is, it actually does not matter which 2 vertices you choose. Because of the symmetry of the system, the result will always be the same. Let's rearrange this circuit so that we can clearly identify which resistors are in series and which are in parallel. Take a moment and look carefully. Between these 2 points, there are 2 possible paths. The first path is the direct bottom branch, consisting of a single resistor of 3 ohms. Now, look at the second path. This path goes through the top, which means these 2 resistors of 3 ohms each are connected in series. So along this path, the total resistance becomes 3 plus 3, which is 6 ohms. Now, observe this very carefully. We have one path of 3 ohms and another path of 6 ohms, and both of these paths are connected between the same 2 points, which means these 2 paths are in parallel. Now, we apply the parallel resistance formula. I'll leave the calculation on the screen for you to work through. Take a moment and verify it yourself. So, the equivalent resistance between these 2 vertices comes out to be 2 ohms, and that is the final answer. Thank you for watching this video. If you found it helpful, there's a good chance your friends and classmates will find it useful as well. So do share it with them. And don't forget to subscribe for more such content. In the next video, we'll solve another question from JEE Mains shown on screen. So stay tuned. I'll see you in the next one.